So good afternoon, everyone. Welcome to our first AP Stats virtual training. My name is Brendan Murphy, and I'm going to be one of our two presenters for the next 5.5 weeks. The other presenter you'll see tomorrow is Luke Wilcox. Luke and I have been friends for years. And so we were both excited to participate in this wonderful opportunity. And we really hope that we're going to bring some wonderful new teaching to some of you, perhaps some concepts that you didn't learn in your classroom. And equally as important, some major review for the AP Stats exam. So first and foremost, I hope you're safe. I hope wherever you are around the country, around the world, that you're healthy, and we're trying to get through hard times for all of us. I'm up in rural Maine, and we do have people in our area that have caught the coronavirus, and our hearts and thoughts are with them. So we hope you're safe. We hope you're at home, and we're going to try the best we can to continue to teach for the next 7 or 8 days, some new topics perhaps, and then we're going to do some AP review. So with that being said, I'm just going to segue right to my PowerPoint presentation. And there's our AP Stats logo. You'll probably see this every day. This will be our first slide as we get rolling. And, you know, kind of a cool little picture there. That's a normal curve there. And, you know, approximately normal looks like sort of a graph in the background. So again, today's lesson is, my name's Brendan Murphy. I teach at John Baptist Memorial High School in Bangor, Maine. Great school to teach at. I've been there for 14 or 15 years. We have great kids. We're a really interesting school. It can be hard to even describe what we are. So we're a 95% publicly funded, independent international boarding school. So in a nutshell, we have around 70 students, international students from around the world. That they come and live in Bangor with us for the year, and we have around 430, 440 what we call local day students. And they live anywhere from 5 minutes to an hour and a half away from Bangor, Maine, and commute back and forth each day to our school. So a really great group of kids, and we're at home now until at least April 27th. This is my second week of virtual teaching with my students at John Baptist, and I'm hopefully getting a little better with Zoom and some other technology that a couple of weeks ago was sort of brand new to me. So again, I'm going to be one of the presenters. Luke Wilcox is going to be the second presenter. You'll see Luke tomorrow afternoon and Friday, actually. Luke teaches at East Kentwood High School in Kentwood, Michigan. We've both taught AP Stats for over 15 years. We were trying to figure out how many years we'd each taught it yesterday when we had some of our trainings. And we've both been AP readers. So we've helped grade the AP Stats exams for years and years and years. And as we kind of dive in and do some mathematics, both of us will bring some of those helpful hints or tips from AP readers. And when we're grading, physically looking at your paper, students' paper, you know, how can students earn points, or sometimes, you know, 1 or 2 words and they could lose a point. So we'll bring all that experience into our different sessions from now until May 1st. We're also both what we call College Board consultants. So on weekends during the school year or weekdays and in the summer, we run professional development for teachers. And so during the school year, I teach kids, and in the summer, I teach teachers. We both love AP statistics. It's near and dear to our heart, and we think you've made a great decision to take this course, and we hope you stick with it, and we hope these next 4.5, 5, 6 weeks can really help you guys out. So today I'll introduce some new math, but I'm really going to focus on why certain decisions were made and those types of things, and give you kind of an overview of our scheduling. So you can see me right now. You'll see Luke tomorrow. Again, we're really good friends. We were both excited for this opportunity. We're kind of jazzed up, and we hope we do a pretty good job for you guys. So we also do some SAT work, and so he and I have worked together literally many times and spoken at conferences and whatnot. So we know each other well. So here's a quick overview of our scheduling again, right up until May 1st. So we're going to meet every day, Monday through Friday, from 2 to 2:45. That's Eastern Standard Time. So perhaps we have people from around the world, and you'll just have to do the math to figure out exactly what time it's going to be wherever you are. But we're going to meet every day, and these all of these sessions will be taped. They're live on YouTube. You can go back and look at them. And towards the end of my presentation, you'll see we have a little homework slide, and I'll show you where you can access those. So here's logic, and there was a tremendous amount of discussion on both sides of the aisle about what this training needed to be. So for the first week and a half, so starting today, March 25th, until next Friday, April 3rd, Luke and I are going to teach units 8 and 9 in the College Board course and exam description, what we have affectionately called the CED. You may have heard that term before. You may never have heard that term before. Doesn't really matter. For all intents and purposes, perhaps the last chapter or two in your textbooks that, based upon Luke and I being on the AP Stats listserv and in talking to lots of teachers, it feels like most teachers around the country, have not gotten to these 2 units yet. So we felt that this was, these statistical topics were perhaps something that you haven't seen in the classroom, or your teacher just hasn't had time to teach it to you. So that was the logic. Unit 8 is what we call inference for categorical data, more affectionately called chi-square. We actually have 3 different chi-square tests that are in the curriculum. And then unit 9 is what we call inference for quantitative data, or inference for regression, or inference with slopes. So some of you perhaps earlier in the year did bivariate data, and you graphed scatter plots and came up with the least squares regression line, something like y hat equals a plus bx. Perhaps other teachers haven't, though. There's sort of a 50-50 split. It seems like some teachers do that earlier in the year, and then other teachers want to kind of combine this at the end of the year. So again, we tried to make decisions based upon where we thought most teachers and students would be. For some of you, this may be brand new, and for others, it could be review, and if that's so, great. So the first 8 sessions, we're going to focus on teaching perhaps new material, units 8 and 9. Starting Monday, April 6th until Friday, May 1st is going to be just AP review, and every day there's a different topic, and we're gonna publish that soon. So I can't overemphasize this enough. These 2 units, units 8 and 9, so chi-square and what we call inference for regression, these 2 units will not show up on your AP Stats exam this year. Okay, nothing that we're going to teach you right now will show up on this year, 2020 AP Stats exam. So then the question is, well, why are you teaching us stuff, Luke and Brendan, that won't be on this year's test? And again, there were lots of good discussions in-house with the College Board and teachers, and we felt, and the College Board wanted to just make sure that all students had access to what we call the full AP Stats experience this year. So whether you're in school or whether you were out of school for the last week and a half, and perhaps some of us will go back and perhaps some of us won't, College Board wanted to at least extend the opportunity for all students around the world to have the full AP Stats experience. So that's why Luke and I are going to be teaching for the next 8 days these 2 units. Again, nothing from these 2 units will show up on this year's AP Stats exam, and I just want to make sure that I stress that. So I'm sure Luke will say the same thing tomorrow. We also felt that in talking to many colleges and universities that they wanted to make sure that next fall, or year and a half, 2 years, depending upon what age you are and what grade you are in high school, whenever you went to the college, next college level, that you did have the full AP Stats experience, and that you have been exposed to these 2 topics. So next year, if you're a senior, we obviously hope you're going to go to college, and clearly you all want to study more statistics, right? Because you had such a wonderful experience this year. Your college professor may say, oh, if you've taken AP Stats, we assume that you've had chi-squared and inference for regression. And so that was kind of the twofold logic behind this. We wanted to make sure that in very trying circumstances for all of us, that we were still able to give students the full AP Stats experience, the full course, And also many of the colleges and universities said to the College Board, hats off for what you're doing. We appreciate it. You know, when these seniors show up on our college campuses around the country, around the world next year, we just want to make sure that they've seen and have been exposed to these topics. So there's no expectation that you'll have mastered these two in the next 8 days with Luke and I, but we do want to do hopefully a good job of introducing them and perhaps explaining some of the logic behind these two units. So that's a little bit about the schedule. Again, every day from 2 to 2:45 Eastern Standard Time, Luke and I will be presenting from now until May 1st. Starting on April 6th, we're going to just review all of the major topics in the AP Stats curriculum that could be on this year's stats exam. So again, from the what we call the CED course and exam description booklet, it would be units 1 through 7, basically up through confidence intervals, hypothesis tests, 1 and 2 samples, means and proportions. So we hope that you're at least have done some of that work: confidence intervals, hypothesis tests, 1 and 2 samples with both means and proportions. If not, again, because you got behind or you know you were out of school earlier than other places, Luke and I will cover all that in our exam review. So we're going to publish that schedule soon, and so you'll be able to plan out your next 5.5 weeks as to perhaps what days you really need to sit in. Hopefully all of them, but if you have other AP courses that are going at the same time, I think AP Calc AB is actually the same time slot. So we want to give you as much flexibility as possible. Again, all of these PowerPoints trainings will be online, and you'll be able to go and watch those on YouTube. We'll talk about different test taking strategies for the AP Stats exam. Again, both Luke and I are AP readers. We've graded thousands and thousands and thousands of AP exams over the last 10, 12, 14 years. And so as we get to different topics, we're going to say, make sure that you watch out for this, or this is a common mistake that we see on the AP Stats exam. So we'll make sure that you hear that as well from us. The College Board will be posting in the next week or so a schedule of all the topics and the dates and the times and what Luke and I will be covering each day. And so that hopefully will give you a better idea of how to schedule out your next 5.5 weeks. You could be having regular classes at school. I'm teaching in the mornings at teaching virtually at for my John Bapp students. So we're all busy. And again, we hope that you can make as many of these sessions as possible. So for this year's exam only, again, it will be a 45-minute test. That's compared to previous years about a 3-hour exam. So we've drastically cut the amount of time and therefore the number of topics that we're going to test. So it will be a 45-minute test. This is for all AP courses, not just AP Stats. It will be just all free response questions, FRQs. Some of your teachers may call them frappies. No multiple choice questions at all on this year's AP Stats exam 2020. The assumption is that many students, if not most or all students, will probably end up taking this exam at home via their computer, tablet, or phone. So the test development committees, each discipline has a committee of half high school, half college that physically write your exams. AP Stats Test Development Committee is probably working as I speak to you right now, trying to redesign the exam for this year. The 2020 exam 2 months ago was done. It was locked up in a vault and pretty much ready to go. And of course, all of our lives have changed dramatically in the last couple of weeks. So the test development committees are in the process of basically writing new exams. 45 minutes, all free response. And we're writing it so that you'll be able to write your answers, type your answers on, again, a computer, tablet, and phone, and then submit them electronically to the College Board. Right now, I'm not sure I know much more than that. Much more detail, if you go down a couple bullets, you'll see will be coming on April 3rd. So again, this revised format is just for this year, the 2020 AP Stats exam and other AP exams. They're all 45 minutes. They're all free response. There could be an exception to AP Studio Art, but for all intents and purposes, all of your AP exams are going to follow this. There'll be 2 different, what we call test administrations. One's going to be earlier and one's going to be later. Probably in May sometime, but those decisions haven't been made yet, so stay tuned. And again, coming out a week from this Friday, the College Board's going to publish when we're going to be giving these two test administrations. And I think there'll just be a little bit more info, how many questions perhaps on the AP Stats exam, how many free response, and those types of things. So when I met with my AP students today, they had 1 million questions, and unfortunately, I couldn't answer all of them. So Luke and I will keep you updated on April 3rd or April 6th, who's ever presenting. We'll make sure that anything that's applicable to this course, you guys get all that information. So what do we really need to know when we talk about chi-square? Well, at this point, if I was still teaching day-to-day, face-to-face at John Baptist, I'd probably be teaching chi-square. This feels like where I should be in my curriculum. And hopefully you've been studying what we call confidence intervals and hypothesis tests with your teachers, probably for the last, couple of weeks, month or so. And so when I get here, most of my kids will say something like, boy, this feels, Mr. Murphy, an awful lot like what we've been doing. And that's a true statement. So this is, if you want to think about it as just another hypothesis test, that's really all chi-squared is. We'll talk about how it's different and perhaps where you can use this. In this unit, there's no confidence intervals. So we just have hypothesis tests. And so again, many of my students would say something like, boy, it feels like there's only half as much work, Mr. Murphy, in this unit as the last couple chapters. And that is a correct statement. So for chi-square, we're just going to talk about hypothesis tests. We do not do confidence intervals with chi-square, at least in this course. So for the next 4 or 5 days, when Luke and I are doing chi-square, there's just one formula for all of chi-square. And I just took this right off of the formula and table sheet that the College Board will produce, and it will be part of your AP Stats exam. So this is right on your formula sheet. Of course, this topic, again, as I said earlier, will not be on the exam, but there's lots of other good formulas. And one of our lessons as we get into April and review will be called Know Your Formula Sheet and Know Your Tables. And so you guys will be well versed in what formulas are given and what not. So chi-squared statistic, it kind of looks like an x squared. It's really not an x squared. I guess it's a slanted x squared. Equals the sum. So sigma, we're going to add up. In the numerator, we have the parentheses observed minus expected, and we square that. So the numerator is always going to be positive. Sometimes if I were to do that difference, I would get a positive number, and other times we would get a negative number. So when we square it, we make it all positive. So we're going to add up a whole bunch of observed minus expected values. We square them. Now they're all positive. And we divide each one of those by what we call the expected value. So the observed that's our raw data. Those are the numbers that we're given, or that we've counted, or that we've done sampled. Expected, there are some formulas that we can use to calculate those. And again, those will come in subsequent sessions. So again, this formula is included on the College Board formula sheet. It's on your AP Stats exam. Hopefully when you all take it in whenever, May or June of this year, whenever those dates come out, you'll see it there, but you're not going to use it. So chi-square, again, is not going to be on this year's AP Stats exam, but we really wanted to make sure that you were at least exposed to that. So chi-square is what we call a non-parametric test. So what does that really mean? It means that we don't make any assumptions about the underlying parent population distribution. We don't need to check for normal distribution. We don't need to check for normalcy. All basically mean the same thing. And hopefully you've been checking your conditions, right? Your teachers have been stressing things to check for to make sure that the tests that we're running are valid. What's sort of nice about chi-squared is we have less conditions. So that's in many ways a good thing. We don't have to worry as much about sample size being big enough to assume at least approximately normally distributed sampling distribution or parent population. So it's what we call a non-parametric test. And we're just not worried about that check for normalcy. We're just not as concerned. If it's not approximately normally distributed, that's okay. And we can still run our test and we can analyze the data. So that was a quick lesson overview of chi-square. And so we actually have 3 different chi-square tests. Luke is going to do goodness of fit tomorrow. Luke will do chi-squared test for homogeneity on Friday, and I'll come back and do chi-squared test for independence. So we have 3 different chi-squared tests. Again, it's just that one formula, so that's sort of nice, right? We just have one formula for these 3 different tests. They are different, and perhaps the one thing that's a little bit more difficult for students is, where do we use each test, Mr. Murphy? I know I just have that one formula, and you told me it was non-parametric. So Luke and I are going to try and make sure that you understand where and how we can use each one of those different tests. Okay, so we have chi-square test for goodness of fit, what we call GOF. I think if we go to your calculator, you'll see GOF. So if you hear GOF, that's goodness of fit. The students of mine who are much more versed in the English language feel like goodness of fit doesn't sound very good. It's how well does it fit? Maybe it should be wellness of fit, but we all call it goodness of fit. And so we'll call it GOF. And I think you'll see I have a couple of problems as we get into the PowerPoint where you can hopefully see where we use each one of these tests. Chi-squared goodness of fit, we're comparing our data to some pre-established model. Okay, that'll make more sense in a little bit. We have chi-squared tests for what we call homogeneity. We don't penalize for spelling mistakes on the AP exam, so don't worry about spelling mistakes. Chi-squared tests for homogeneity, I'm oversimplifying a little bit. Think we have 2 different populations, and we want to compare one variable between those 2 populations. Many times when we're doing a chi-squared test for homogeneity, data is presented in what we call a 2-way table. So we'll take a look at that. And then we have what we call chi-squared test for independence. That's maybe the opposite of homogeneity. We have one population, but 2 or more variables that we're comparing within that population. So again, we have these 3 different tests. We need to, our students are required to figure out, which test goes where, when do I use chi-square goodness of fit, when do I use homogeneity, when do I use independence. That can be tricky. And I say to my students, when in doubt, just put chi-square down, chi-square test, and then try and put all the other information that we're looking for, and don't stress over it. But probably the hardest thing, and we'll practice this next couple days, is figuring out what test to use, and then coming up with the null and alternate hypothesis, which is almost always in words. So that may be easier than using the correct statistical nomenclature symbols. But my students tend to struggle a little bit with the null and alternative. We do need to calculate degrees of freedom. So degrees of freedom, perhaps similar to what you did with means. I introduced the concept degrees of freedom probably in the first or second week of AP Stats way back in August or September when we're doing standard deviation, and we divide by n-1. I don't know if you remember that way back in September. And then when we're doing our correlation coefficient, calculating our R value, that formula has it. And at times it's a really elusive concept for students. And sometimes it's not until we get to chi-square that the students really start to understand what does this whole concept, what do you mean degrees of freedom, Mr. Murphy? What do you really mean by that? So there's a couple different ways we can calculate degrees of freedom depending upon what test we're working on here. So again, Luke and I will cover all this when we actually dive in and do some of the problems. We do need to check conditions. So when you were doing means and proportions, different teachers have different acronyms about what conditions we need to check and what assumptions are we making. None of these tests have any validity if the conditions aren't met. We're using the wrong test in the wrong place. So for chi-square, we do need to check conditions, but it's just these 3. So we need to make sure that our data was randomly selected from the population. Most of the time, that's literally right in the stem of the problem somewhere. Data was randomly blah, 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 blah. And so that's easy. And many times it's in the stem of the problem. And I would just instruct my students to just write it down. Data was randomly selected as stated in the stem of the problem. So without random selection, this test is it's not valid. We just can't use it. All of our expected values are at least 5. So I'll just go back to the formula. You can see that in my denominator is my expected values. If that's a really small number, that's going to make the chi-squared statistic really big. And that's going to lead us ultimately to what we call a low p-value, low probability of something happening. And so if we had a really small expected value, you know, less than 5 or decimal, it might artificially make this chi-squared statistic larger than it should be. And it might lead us to reject the null hypothesis when perhaps that may not be the best decision. So we need all of our expected values to be at least 5. And that could, again, show up on a multiple choice. Of course, not this year, but in previous years, you know, we've tested that on a multiple choice, and on a free response, we would just want students to list this. Again, no chi-squared on the 2020 exam. And again, what we call the large count, our population is at least 10 times our sample size. So if we have a sample size of 50, we want our parent population to be at least 500. And that's most likely going to be an assumption. That's probably something that you mathematically can't check. Many times we don't even know how big the parent population is, but you know, it might be reasonable to assume that the number of M&Ms, blah, 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 or the number of students that go to a large college. I think I have a couple problems that will address that. So so non-parametric tests, all 3 of these chi-squared tests are what we call non-parametric. We don't need to worry about that normal shape. But we do need to make sure that our data was randomly selected. All of our expected values are at least 5. And we need to check that large count, make sure that our population is much, much, much bigger than our sample size. So a chi-squared table will be included in your formula sheet in table component of the AP exam. So you're going to get a list of formulas. There's 2 pages of formulas. Chi-squared will be on that. Of course, we won't use it this year. You'll get, I think, 2 pages of a z-table, 1 page with a t-table, and 1 page of what we call a chi-squared table. Again, I took a picture right from the AP Stats exam. I don't have the whole table, but your chi-squared table is going to look something like this. If you notice over here on the left-hand side, we have degrees of freedom. These numbers in the body are our chi-squared statistic. And then if we look along the top, we have our upper tail probability. And so again, Luke and I will actually walk through some multiple choice. I'll do a couple multiple choice today, and Luke will probably get into some multiple choice and free response tomorrow. Our calculators can run all of these or perform all of these tests for us, no different than means, proportions, confidence interval, hypothesis test. Depending upon how I'm doing for time, I can show you where these are in your calculator. I mean, we do want students to use their calculators. We don't necessarily want them to do all of these computations on a piece of paper. You are allowed to use your calculator and type your data into matrices and run a chi-squared test and come up with our chi-squared statistic, degrees of freedom, the probability. Again, hopefully you were studying this before a school was out, and some of these concepts hopefully make sense. But you will have a chi-squared table on your AP Stats exam, and you can and should be using your calculator for any problem that you see fit, or any problem that's applicable. So let's actually look at a couple of AP problems. And let's see if we can figure out why these might be different than a mean or proportion problem. So if you've been studying hypothesis tests, you know, let's take a look at a problem and see how this may be different, okay? So let me give you just a minute or so, a couple, 30 seconds to just read through this problem. And then we'll go through it. And I won't actually run the whole test, but I just want to show you what a chi-squared problem could look like. So I'll give everyone 30 seconds or a minute, read through the problem. I'll read through it as a group, and then we'll talk about why and how is this different. Okay, so this was from the 2002 multiple choice, the 2002 exam, and it was a multiple choice question. Brown eyes, green eyes, and blue eyes. I use this with my students every year. I think it's kind of a neat little multiple choice problem, and we actually record people tell me what color their eyes are, and we actually come up with our own data. But in this problem, a geneticist hypothesizes that half of a given population will have brown eyes, and the remaining half will be split evenly between blue and green eyed. So I read that and I say about 50% will be brown, and 25 will be blue, and 25% will be green. Notice that the data above is in what we call counts, numbers. Many times chi-squared is given to us as percentages, so the 50%, 25%, 25%. So we need to convert at some point those percentages into counts. So for chi-squared, if you see percentages, just note to self that we need to convert those into count numbers. In a random sample, so that's good. I guess we got our randomness in there. Of 60 people from this population. So we took a random sample of 60 people from a population. The individuals are distributed in the table above. So we randomly sampled 60 students at a large school. 34 had brown eyes, 15 had green, and 11 had blue. Those are what we call observed. So that's the actual data values. So those are our observed values. If my math is correct, 50% should have brown eyes, so 50% of the 60 would be 30. So I would expect to get about 30 brown eyes. 25% of the 60 people would have green eyes, so well, there's the 15. So we observed 15, we would expect 15, whereas brown we observed 34, and we expected 30. For blue eyes, again, 25% of 60 would be 15. So we observed 11 students had blue eyes, and we expected, or we thought we would get about 15. So I would just say to my students, how does that feel? Do these numbers look reasonable? Are they close? And we sort of get a good discussion going. This is day one of chi-square. They don't know how to run the test yet, and I don't expect them to. So we have some data that we collected. We have 60 people, 60 data points. And in goodness of fit, we're comparing that to some model, some determined model. And so in this case, it was the 50% brown eyes, 25% green, and 25% blue. So this feels like a goodness of fit to me. I have some observed data, and I'm comparing it to a predetermined model. So how does this feel different? Well, up until now, we had one sample. Then we went to two samples, but we've never really been able to deal with three different groups or categories, right? Up until now, we've been sort of limited by what we call one sample and two sample. And I guess with chi-squared, we can have multiple. We could have 10 colors of different eyes. And so chi-squared sort of opens up the door to potentially more scenarios where we don't have just one or two samples. We in this case have three different groups or three different categories. What is the value of the chi-squared statistic for the goodness of fit test? Again, we won't actually run the test. I just want to sort of throw this problem out and show you how maybe it feels different, and that's a good thing. This would be kind of a classic goodness of fit test. We have some observed data, and we want to compare it to some predetermined model. In this case, the predetermined model was 50% blue eyes, 25% green eyes, 25% blue eyes. Again, percents, many times we have to convert those over to counts, raw numbers. So here's another multiple choice question. Again, let me just give you 30 seconds to read it and see if this feels different than what you'd studied before, and does this feel like perhaps it could be chi-squared? Okay, so this was from the 2007 table below. So it looks like we have four different types of flowers that were crossbred. We have magenta flower with green stigma. We have magenta flower with red stigma. We have red flower with green stigma, and red flower with red stigma. So we have four different groups or categories. Again, we have some observed counts over here on the right. So there were 115 magenta flowers with green stigma. There were 49 magenta flowers with red stigma, et cetera, et cetera, et cetera. So these are counts over here. And again, hopefully you're saying up until now, we've had one sample, two samples, but we've never sort of been able to incorporate these 4 different groups or categories. And this is where chi-squared sort of kicks in and can help us. So a biologist, expected that the ratio of 9 to 3 to 3 to 1 for the flower types respectively would result from crossbreeding experiment. So here's the predetermined model. Okay, here's the predetermined model. And we're comparing our observed values, the 115, 49, 32, and 21, to this expected ratios. So again, here's where I have to probably do some math, right? I would have to add up those totals and then put their corresponding proportion, 9 to 3 to 3 to 1. And I would come up with expected values. So in chi-squared, we have observed. That's the data we have. We many times mathematically will calculate what we call the expected values. And we would write those on our paper somewhere, and then I would go back to that one formula and plug it in. And again, Luke and I are gonna actually walk through some problems, both multiple choice and free response in the next few days. Today was really just setting the stage and trying to give you a little bit of the logic of what we're gonna try and do in the next 5.5 weeks with you guys. So one more multiple choice. And I think this actually might be your homework. Yes, it's your homework for this evening. So let's read through that. And then we'll talk about homework. You don't need to stress about your homework. This could be just something that you want to think about before tomorrow. And Luke will start out with this problem tomorrow. So he and I are in constant touch with each other. We'll be talking each day for the next 5.5, 6 weeks. And we'll be talking about what worked, what didn't, where did you leave off, those types of things. So he's excellent. I think you're going to really like Luke as well. And hopefully he hits the ground running and he'll start with this problem. So again, let me just give you 30 seconds or so to read it. You can look at the answer choices here and we'll try and talk about it and then we'll wind down for today's session. Okay, so 2012 exam, multiple choice question number 30. In order to plan its next advertising campaign, the trendy motor vehicle company is investigating whether the type of vehicle and the color of vehicle are related. Okay, so I'm going to call this a two-way table. I have 2 groups of categorical variables, and I want to see, is there some relationship between the color of the vehicle versus the make of the vehicle, vehicle type, car versus truck. No idea by looking at those numbers right now whether there is or isn't. Each person in a random sample of size 275 selected from the company's mailing list was classified according to the type, car or truck, and the color of the vehicle he or she drove. I imagine if I add up all those numbers, I'm going to get 275. Again, I would call this a two-way table. And anytime we have a two-way table, we're basically looking to, one of the things we're looking for is to see, is there some relationship between these 2 categorical variables? Is there a relationship between vehicle color and vehicle type? In other words, are there more red trucks than red cars? Are there more black cars than trucks? Who knows? Okay. Which of the following procedures would be most appropriate to use for investigating whether there is a relationship between vehicle type and color? So I won't give you the answer. Probably it's going to be chi-squared, right? Because that's what I'm doing today. But let's look at the answer choices. A 2-sample t-test. Okay, well, do we have 2 samples? And are we dealing with means? A 2-sample z-test. So again, do we have 2 samples? And we do z's with proportions. So is this 2 samples with proportions? A matched pairs t-test, again, that would be with means. And we sort of have a before and after. They're not independent, okay? They're dependent upon each other. chi-squared goodness of fit. So we did that a little earlier today. Chi-squared goodness of fit. We collect some data and we want to see, how well does that data line up to some sort of predetermined model or predetermined relationship. I'll leave that up to you guys. And then chi-squared test for independence. I'm going to do that next Monday, but keep in mind what a chi-squared test for independence is. We have one population, and I want to compare two or more variables within that one population. So I'll leave that up to you guys, and that'll be your homework. All of these sessions are being recorded. They're on YouTube Live. I'm streaming live, I think, right on YouTube. They're also going to be posted at this website, www.statsmedic.com/YouTube. Luke, who you'll see tomorrow, he's one of the founding fathers, the architect of StatsMedic. I don't know if any of your classes or teachers are using it. So he's graciously said that he's going to post all of our sessions on StatsMedic. And so you'll be able to find the homework there. And if you go to that, if you're on, I think you're all on YouTube right now. If you go down and scroll under descriptions, you'll also find this link to that same website. So real quick, let's debrief and summarize what we did today. So today was set the stage. We're glad you're here. Again, I hope you're safe at home and healthy, and that we get over this as quickly as possible as a country and a world. For the next 5.5 weeks, Luke and I will be running these afternoon sessions from 2 to 2:45 each day. From now until April 3rd, Friday, April 3rd, we're going to be reviewing units 8 and 9. And those, again, will not be on this year's AP Stats exam. So the 2 units that we're doing for the first 8 sessions will not be on your AP Stats exam. Anything else that you've had during the course of this year, units 1 to 7 in the College Board's CED, are clearly potential topics. And Luke and I have a 20-day plan as to how we can best help you get ready for the modified AP Stats exam this year. So I want to introduce the 3 different chi-squared tests. They're all hypothesis tests. There's no confidence intervals. And there's the 3 different tests, what we call chi-squared goodness of fit, chi-squared test for homogeneity, and chi-squared test for independence. And that's where we need to put our thinking caps on and figure out, looking at this problem, which of these 3 tests do we use? The formula is the same for all of them, so that's kind of neat. That makes it a little bit easier. And the assumptions and conditions that we need to check, well, there's only 3 of them, and it's a whole lot less strict perhaps than means and proportions, where we really had to make sure that we were checking lots of different things. And you have a little bit of a homework. We went through the schedule. We talked about the AP Stats exam, how that's modified. We did a quick overview of the 3 different chi-square tests. And we want to sincerely thank you, the College Board, myself, and Luke, who you'll meet tomorrow, for joining us. I'm sure you guys are super busy. We're busy. We're working really hard to get this, hopefully, wonderful training in front of you guys. And it's a little awkward to not see any faces or have any students raising their hand, Mr. Murphy, Mr. Murphy. So that's going to take a little bit. Luke and I will adapt real quick, and we'll figure it out. But I hope there's hundreds, if not thousands, of students and perhaps teachers watching us today. And we hope that you keep coming back day after day. We are going to post a schedule of what different things we're going to do, and that's going to be soon. And as soon as it is, Luke and I will make sure that we post that as well. So you do have a practice question. I'll just scroll back up to it real quick. That's your homework real quick. Maybe read through it again and look to see, is it A, B, C, D, or E? And if so, why? How did you make that decision? That will be posted at this website, www.statsmedic.com/YouTube. And Luke will pick up tomorrow, same time, 2 o'clock. I'll see you guys next Monday. So I have right around 2:45, and that's when we said we would go to. So I timed it well, I guess, today. So thanks again. We really appreciate it. Luke and I are pretty jazzed up about this, and hopefully we get in the groove quickly, and you guys can tune in and watch this as many days as possible. So please be safe. Please take care of each other. Please take care of your families. I'm going to sign off now, and you'll see Luke tomorrow. I showed you his little picture there at the beginning of the presentation, and I'll see you guys on Monday. So thanks again. Be safe. I'll see you Monday, and you'll see Luke on Thursday and Friday. Thanks.